Hello friends and welcome to my channel. In this video I will present you this night charger for my solar battery. I will explain you why I did it and how I did it. First of all, I want to tell you why I made this night charger. I made this because I wanted that my system to be off-grid during the day and off-grid during the night. In the day when we have sun, my solar panel charge solar battery. But during the night I wanted to use this to maintain the battery, to extend the life of the battery as long as I can, because I noticed that when I don't use a night charger, especially in the winter, when we had 2 or 3 days without the powerful sun, my solar battery discharge, and that's why I made this charger. As you can see, this charger is made from an old PC power supply. Now I will tell you what I needed from this power supply, this charger. So I need a charger, then can be turned on and off but with this wire. This wire goes to the plus of the solar panel, and when here I put a voltage, this charger shut down. In the night, when here it's no voltage, then this charger starts and charge this battery, solar battery. Now I will use this battery as an example. And also I want that this charger not make power consumption when it's not in use, and that's I modified this schematic. First of all, I took off standby 5 volts and standby 12 volts, that is power supply from main power supply, and this charger starts only with a battery. Now I will show you. I will turn the power on. Now the power is on. As you can see, without the 12 volts here on the output, this doesn't start. Let's take a look at the power consumption. It's 1 watt. I believe that is the power consumption of this power meter. Now I will connect this battery to the output of the charger. As you can see, charger starts. We have 14 volts on the output and 0.3 amps current consumption for charge this battery. Now I will emulate that I connect this solar panel. When I connect this, ground is put here, and this is plus 20 volts. When I put here plus 20 volts, As you can see, the charger stopped, and this is the voltage on this battery. Let's check the power consumption. It's 3 watts. Now let's check the power consumption on charging. It's 10 watts. Now this battery is fully charged, and that's why it's so small power consumption. Now I will make a short version. During the day, when I put here voltage, the charger turns off. During the night, when the solar panel doesn't deliver this voltage, the charger starts and maintain the solar battery to not discharge and charge completely if was not fully charged during a cloud day. I made this charger 5 years ago and works perfectly until now. Now it's working. I want to show you this charger. What I want to show you, I hope that you can see, this capacitor, it's not good. As you can see, it's defective. Also, this capacitor, as you can see, it's not good. So I have to change these two capacitors from other power supply, change this capacitor, and make the adjustment for the output voltage. This is the fan control speed, and this is the on and off switch, automatic switch from this wire. Now I want to show you something very interesting. First of all, I will start the charger. For this, I have to put this battery on the output and start the power supply. As you can see, the charger starts because think that is night, because here it's not 24 volts. Now, what I want to show you. As you can see, with the load, output voltage, it's 14 volts. When I take out the load, as you can see, the output voltage jumps to 20 volts because of that fat capacitor. And now if I put a good capacitor instead of load, as you can see, now the voltage is good. It's 14.5 volts. I wanted to show you that when this filtering capacitor it's bad to a power supply, SMPS power supply, then the output voltage is not stabilized, and because of the duty cycle, output voltage goes to the maximum because of the maximum duty cycle. When I take out the capacitor, you can see the output voltage. Now I want to show you this on oscilloscope. I put to the AC to see if the voltage is good or not. As you can see, now with the capacitor, the voltage is good. Now let's take the capacitor out. Now you can see we are on AC, and this is how the output voltage looks when this filtering capacitor it's fat, it's dried. And if we put again the capacitor, the output is perfect. And that's why we have to check the capacitors and replace when does not have the good parameters. Now I will take all apart and I will change the bad parts. I've replaced that bad part, and now let's check with this tester. It says capacitor 31 picofarads. So this is dead. Let's check these big ones. This one is fat. This one is not yet fat. I want to discharge this before to put to the tester. This one is capacitor 250 microfarads and 1.5 ESR. This one it's not dead, but almost dead. And now let's check this one. This one looks very good. This one is perfect. It says 275 microfarads and ESR is 0.4 ohms. This one is perfect. I will keep this one, and this one I will throw away. Now let's start this power supply. I've replaced bad parts and I made some changes. I took off these shunt resistors from here and I modified output voltage. Initially was 40.5 volts, but this is the charge voltage for a battery like this. I modified it to 30.5 volts because this is the best voltage for float. First you have to fully charge the battery to the day, and to the night it's only necessary to keep it to the float for the battery to have a very long life. Now let's power this up. Now it shows 12.8 volts from battery. Let's power this up. Now it's 30.5 volts output. And let's check what happens when we take the load off. As you can see, the voltage remains good even if I take the load off. I hope that you liked this video. See you in my next video. Bye now.